All right, so the PEP we're doing is PEP 227, which is statically nested scopes. And team members are Louis Bouddhou, Alex Campbell, and Josh Fermin. So there are two main problems that this is addressing. One, that we cannot reference a variable in a higher order function, nested function. So you can't reference variables from one function that is nested within another function. And with that, static scoping doesn't actually work within those nested functions. So an example without statically nested scoping, in this example, our balance variable that is defined right after account balance, our bank account, is not available in the def deposit. So this would not actually work if we didn't have static scoping. So the introduced changes will give nested functions the scope of outer functions, meaning nested functions will have access to variables in outer functions. So this allows the variables within the parent function to be inherited by the nested function. So one thing that addresses is the utility. So it's pretty tough to create good programs when you don't have nested functions, and it adds some utility to programming. So here's an example of added utility. So without nested scoping, static scoping, you have to redefine root, and that command equals lambda because it is not within the scope. But with static nested scoping, we don't have to define root again. So it also addresses the problem of non-lexical scoping. So most developers are used to using lexical scoping, which is static nested scoping. So when they come into Python, it's much harder to get started. So an example of that is without static scoping, the adder here, the base would not be available. But because we've added static scoping, the base is available, and this function would return 11.
All right, so namespaces. So whenever you start a Python script, it will order names in different contexts to avoid ambiguity. A local one, a global, and a built-in one. And the first one is the local namespace. So the local namespace is pretty much one that starts when a function gets created or called and ends when the function returns or throws an error. And in this example, the variable foo lives within the namespace of the function called local in that example. And then there's a global namespace, which is one that runs like in the outermost module, just a module, so outside of the local namespaces. And here, the variable bar is in the global namespace, outside of the function called global. And then there's the built-in namespace, which is the outermost one, which contains all the built-in names and functions and whatnot that live in the Python interpreter. And here we used list in that example, which is a built-in name. And then the way names are bound is always within the scope of wherever they're referenced in. So if a name is repeated several times within a block, it will always refer to that same namespace. So here, local. And the way it's searched through those contexts is it goes through the local, then the global, then the built-in. And in that example, list, for example, to not avoid ambiguity, will always go to local first, and then goes outside of the function and sees the other list, which was built in.
All right, so now on to the discussion. The rule that nested functions can be used as variables declared in the surrounding namespace will work under all circumstances except for the following cases. 1, the name in the class scope, and 2, the global statement will short circuit under the normal rules. All right, so first, the name in the class scope. The variable names will be resolved in the innermost nested function, and this is to prevent odd interactions between class attributes and local variable access. And the second is the short circuit. The global statement will be unaffected by this change, and wherever the global keyword is used, it will refer to the global namespace instead of the function namespace. And on to backwards compatibility. Two kinds of compatibility problems are caused. One is code behavior before and after the change, and syntax errors being caused after the change. This first example shows how code behavior will change because of this PEP. Before this PEP, it would print 1 because the inner scope would not get the scope of the f1 function. After this PEP, it will print 2 because it will now inherit the scope of the f1 function. And this example shows how syntax errors will be thrown after the change. It's because function g will not know which y to refer to, either the global variable y or the local variable y. And overall, the changes in this PEP are beneficial even though nested scopes aren't used that often. And the only problems lie in backwards compatibility.